So let's start from where we stopped in the last class. So in the last class we were discussing the NumPy library, right? So let me just discuss like a quick functionality of the NumPy library, and then we can move on. We discuss some functions that we can use for the NumPy library, right? So we can use, for example, the sort function to sort the rows or columns of the NumPy library. If I do not specify the axis, it will just sort on the last axis. Otherwise, I can specify x is equals 0 or x is equals 1, right? Similarly, I can compute the mean of arrays. I can multiply the arrays. I can do matrix multiplications. I can do element wise multiplication. So all those functionalities are there in the NumPy array. For example, for matrix multiplication, I use the dot function, right? For multiplication, for element wise multiplication, I can use dot multiply function. For similarly for element wise division, I believe the function is dot divide function, right? So yeah, there are all these different kinds of functions that are available in NumPy that are specialized for arrays. Good. Now just let me give you another quick example of the functionalities of this NumPy package. For instance, you might have remembered linear equations, right? Do you remember linear equations? Yes. Yes. So some yes, some don't. So linear equations is essentially a collection of some linear equations because they are defined some lines in some dimensional space, right? And when you want to solve those linear equations, you basically want to find those values of the variables that satisfy all those equations, right? So for instance, let's say I write an equation which is 7 times x1 plus 2 times x2 plus, sorry, minus, let's say I have minus 3 times x3 equals minus 12, right? And then I have another equation, 2 times x1 plus 5 times x, not x2, yeah, it's linear equation, x subscript 2 minus 3 times x subscript 3 equals minus 20. Then I have another equation which is x subscript 1 minus x subscript 2 minus 6 times x subscript 3 equals minus 26. So this is a system of linear equations that has 3 equations in it, right? And it has 3 variables. So if all these equations, or the planes that are determined by these equations, they intersect at one point, so I will be able to find the solution. Yeah. So we can do the same thing in NumPy as well. Now you might remember, if you had studied matrices, most likely you have studied matrices, you can represent this system of equations with something like A times matrix A times x equals a vector B, right? So you can write the same system of equations in the matrix form as 7, 2, minus 3, then 2, 5, minus 3, then 1, minus 1, minus 6, times this vector x1, x2, x3 equals b1, b2, b3, which is minus 12, minus 20, and minus 26. You know this, right? I mean, you can write the system of equations in a matrix vector form as well. So 7, 2, minus 3, 2, 5, minus 3, 1, minus 1, minus 6, and then this b is x1 minus 12, minus 20, and minus 26, right? So we can solve the system of equations in NumPy as well using the functions that are specific for linear algebra, right? So let me just define these matrices first. So I can say A equals, before I do anything, I need to import NumPy. I say import NumPy as NP, right? And I say A equals NP dot array, right? And then I can define the array that I have over here: 7, 2, minus 3, 2, 5, minus 3, and 1, minus 1, 6, right? So I can just create a list of lists, or 2D list. So I have the first entries are, I have 7 2 minus 3, 7 2, and then I have minus 3, and then the next list I have is 2 5 minus 3, the next row, 2 5, again minus 3, and then we have 1 minus 1 minus 6, 1 minus 1 minus 6. So 7 2 minus 3, 2 5 minus 3, 1 minus 1 minus 6, 7 2 minus 3, 2 5 minus 3, 1 minus 1 minus 6. Okay. So this is the matrix A. Then I can initialize the matrix B, for example, right, which is np dot array, and then I can have, I want to make a vector, right. So for that reason I want to again will write a 2D list, but each entry will have just one value. So minus 12, I have minus 20, right, and then I have minus 26. Now if I just run these, yeah, it's going to connect to a server at somewhere in Google servers. Yeah, it ran these, right. So it initialized a matrix A, which is this one, matrix B, which is this one, and we can print the values. I can just say print A, and I say print B. You see, this is the matrix A and this is the matrix B. Okay, and there is a function in Python which also, you know, tells, for example, what is the shape of the matrix, right. To know what is the shape of the matrix, you can just say the matrix, you know, value, the matrix name dot shape. If you run this, you will get what is the shape of the matrix, right. Similarly, B dot shape, you can see it's 3 by 1. You have 3 rows and 1 column. And A dot shape is 3 by 3. You have 3 rows and 3 columns. Okay. And then how we can solve for x? You can use a function in NumPy that is for linear algebra. Is np.linalg. That will just get you to the functions that are specific to linear algebra, and then dot solve, and then you have A and B are the inputs. If I do that, and then I can just print x. So this is the solution. So x1 is 0.71875, x2 is minus 1.46875, and x3 is 4.697. Yeah. In this notation, you know, you remember when we were discussing classes, right? To access a member function, what did we do? We wrote the name of the class, and then we said dot, and then the name of the, you know, the member function, right? Here what do you have? You have a class inside another class. So np dot, you know, this linalg, right? It contains the collection of functions that are specific to linear algebra, and then in that you have the function dot solve, and that is how you are just solving the this system of linear equations that contains the matrix A and B of these values. And similarly, you know, you can have it doesn't have to be system of linear equations. You can have, let's say, quadratic equations. You can solve them in NumPy. You can have here you just use 3 variables. You don't have to have 3 variables. You can have 10 variables. You can solve it with this dot solve function, and so on and so forth. Questions till this point? Yeah. So similarly, there are other functionalities of this NumPy package, right, that are specific to arrays, and those are very useful in engineering computations. Okay. So this was about NumPy.